Good morning. I'm going to give you a quick rundown of today's lesson. These notes from last class, they are blue. Oh, there they go. You have these in your notebook. Yours just look blue. So mine's here on the screen that you can see. We focused on this top part yesterday, remembering our inequality symbols and how to solve two-step inequalities. Today, we're still going to solve inequalities, but we're also going to graph them. So this bottom portion is a good reference to look at. So you can use your symbols to figure out which style you are graphing as. So the first thing we have to determine is whether the circle is open or closed. Open or closed. So this one's open and this one's open. See how the greater than and the less than are open? That means our number that we have there cannot be a solution. It's not equal to that number, so we can't touch it. So it's going to be open. And if you look visually, see how there's no line underneath those? No line, no touching. All right. See how this greater than or equal to and less than or equal to have that or equal to line underneath? That means our solution could be true, so it's a solid dot. And we'll look at that more a little bit later. Then we figure out which side to color on. That makes it true. So if we look at this warm-up here, our graphing warm-up, this should be review, but we're reviewing it from last year. If x is greater than or equal to -2, well, we know -2 is where our circle will be. We just have to figure out if it's an open circle or a closed circle. Well, see how it has the or equal to line underneath? That tells us that -2 could be equal to -2, so that is a solid dot. We're going to color that in. All right, so we figured out whether it's open or closed. Next, we pick a value to substitute in for x to see if it's true. So if we substitute in 0, so let's think to ourselves, is 0 greater than or equal to -2? Yeah, 0 is bigger than -2. 0 is greater than -2. 2 is also greater than -2. 4 is greater than -2. 6 is greater than -2. So all of these answers over here to the right are greater than -2. So we're going to draw our arrow to the right. Look, we graphed it. Pretty easy. That's it. Number 2, x is less than 5. So we know 5 has our circle. Is it going to be open or closed? Well, we look. Is there an or equal to line? No, there's not. So we can't actually touch 5 because 5 is not less than 5. That's not a true statement. 5 is not less than 5. It's equal to. So since that's not true, we can't touch the 5. So it's going to be an open circle. So we're not touching it. We can get really, really, really close, but we're not going to touch it. So that's what that symbol represents. And we have to figure out which numbers can fit in x to be true. Now, again, I like 0, right? So we can substitute in 0 to see if it's true or false. So let's see. 0 is 0 less than 5. Yeah, 0 is less than 5. Sweet. 1 is also less than 5. -5 is less than 5. -6 is way less than -5. So it's all of these over here to the left. So you can color that in. Ooh. And draw an arrow at the end because everything even further than -6, like -258, also is less than 5. All right, next one here. As we go through. All right, so number 3. Is it open or closed? Open or closed? Well, we look, see how it has that or equal to line underneath? That tells us it's a closed dot at 6. And then again, I like to pick 0. Is 0 less than or equal to 6? Well, is it? Yeah. All right, so we color on the side where 0 is. Since 0 is on the left, we're coloring everything to the left. And we draw our arrow. Number 4, x is greater than 1. So at 1, we see if we have a dot that's open or closed. Open or closed. See how there's no or equal to line underneath? We can't touch it, so it's going to be an open circle. Now, we pick 0, right? If I pick 0, is 0 greater than 1? 0 is not bigger than 1. No, which means we can't color on this side. We're actually going to color on the other side. So let's see if we can make something that's true. Let's see, is 3? Let's plug in 3. Is 3 greater than 1? Yes. Is 5 greater than 1? Yes. All of these numbers over here to the right are greater than 1. So I usually check 0 And then if it's true, I color the side with 0. If it's not true, I color the other side. But it's always good to check just in case to see if the other side works as well. So that's where we're going there. All right, here we go. Number 5. Is it open or closed? Open or closed? This should be getting easy. It's open because there's no or equal to underneath. Oh, not at 14. Do you see my mistake? That is a negative 14. So we need an open circle at negative 14. We can check 0. Is 0 less than negative 14? No, 0 is bigger. That's nearly a whole number. So we color on the other side. The arrow goes the other way. All right, final one we're doing together. X is less than or equal to 9. Well, it's a closed circle because of the or equal to sign here. So we close our circle at 9 and we're going towards, well, is 0 less than or equal to 9? Yeah, 0 is less than 9. So everything to the left. And there you go. So if we were to solve and then graph, we could do just like we've been doing. I like to do the train tracks. I don't know if your teacher does that or not. You are welcome to. So we separate it out. We're going to get rid of our constant plus 2 first. So we do the opposite of adding 2. So we're going to subtract 2. Whatever we do to one side, we do to the other. Those 2's are gone. We are left with 5. X is, be careful, that's a less than or equal to symbol. 17 minus 2 is 15. All right, from here, since 5 is being multiplied by x, we can divide both sides by 5, which leaves us with 5 divided by 5, leaves us with 1x, less than or equal to 3. So from there, we have a dot at 3. See how it has that or equal to line underneath? So we know it's a solid dot at 3. And then we can check 0. Is 0 less than or equal to 3? Yes, it is. 0 is smaller than 3, so our line goes this way. Good to go. I'm going to skip down to number 3 and do that one next. So if we draw our train tracks here, all right, the tough part is which one do we get rid of, the 9 or that negative secret 1 that's sitting out there? Well, we do the inverse operation of this plus 9, which is minus 9. Whatever we do to one side, we do to the other. So that way 9 minus 9 is nothing. We are left with, be careful, that x is negative. That is a negative x. Greater than 10 minus 9 is 1. From here, that is that secret 1 sitting out there. So to get rid of it, we can divide both sides by a negative 1. Bum, bum, bum. Do you remember from last class? We are multiplying or dividing by a negative. Something happens. Something happens when we multiply or divide by a negative. Are you ready? The negative 1 divided by negative 1 leaves us with a positive x. That greater than changes to its opposite as a less than symbol. And 1 divided by a negative 1 is a negative 1. Be so careful. So if we multiply or divide by a negative, our sign flips to its opposite. From there, we can graph as we have always done. So what we can do is we can put a dot at negative 1, and it will be an open dot because there's no line underneath, so it's an open dot. And then we check, is 0 less than negative 1? Is 0 less than negative 1? No, it's bigger than, so we color the other side. So you can check those as well. You can say, oh, is negative 5 less than negative 1? Yes. Good to go. All right, I'm going to do number 5, and then you're going to do the 3 on the right on your own. So here we go. Train tracks, choo-choo. All right, so we're going to get rid of that minus 5 here by doing the inverse operation. And the inverse operation would be to add 5. Whatever we do to one side, we do to the other. Negative 5 and 5 give us nothing. We are left with 2x is greater than 6. All right, from here, to get rid of that 2, we can divide both sides by 2 because that 2 is being multiplied by x, so the inverse operation is division. 2 divided by 2 is 1x. Greater than, we just divided by a positive, that's fine. 6 divided by 2 is 3. So it's only if you multiply or divide by a negative. From here, we need a dot at 3. It is open because there's no line underneath. It is not equal to 3. So we can't touch it. And then we check, is 0 greater than 3? No, 0 is not greater than 3. Okay, let's see on the other side. Is 5 greater than 3? Yes, so that's the side we're coloring on. There we go. Good to go. All right, so try 2, 4, and 6 on your own and bring this next class.